Okay, let's take a look at the difference between equals and equality in Java. So we're going to start by declaring some integers. So here we'll declare x, and then we'll assign it the value 3. Okay, let's declare an integer y, and we'll assign it the value 5. And then we'll declare an integer z, and we'll assign it the value 8. So in my print statement here, we're going to take some string literals, concatenate them with their integer values that were stored in variables. So let's go ahead and compile that and run. And there's our values. X is assigned 3, y is 5, z is 8. Now, if I do some comparisons here, if I want to check and see, is x equal to y? Okay, this this compound equal sign, this is asking, is that a true or a false result? So is the value of x equivalent to the value stored in the variable y? Okay, that's a Boolean that's going to be returned. Then let's check and see if x plus y, so let's add those together. And then we'll use that equals again and see if that value is equal to z. So let's go ahead and compile and run. Okay, and here's our output. X is 3, y is 5, z is 8. We check to see if x and y are equal to each other using the equals to check for equality, and that returned false, right? 3 does not equal 5. But when we added them together, 3 plus 5 is 8, and then we compared with equals to see if that was the same value as z, and since 8 equals 8, the Boolean expression returned true. Okay, so now we know, take some notes here, that the equals operator checks for equality in numeric values. Okay, another thing that we can look at is the not equal operator. And the not equal, that exclamation point reads not. That's checking for inequality in numeric values. So for instance, we want to use the not operator. We can ask this Boolean expression, is x not equal to y? Since x is 3 and y is 5, that's a true statement, right? That should return true because 3 is not equal to 5. So we'll go ahead and compile and let that run. And there's our true results from that statement on line 13. Okay, some other things that we can look at would be, so if I wanted to do some math with my variables. So let's say I took the value x and it's already been declared and assigned 3. What if I want to add 1 to that value? So x is now equal to x plus 1. And I'm just going to copy this and paste it down here so we can see what those values are. Okay, so I'm going to add 1 to the x. Okay, let's take the y value. We're going to take the current y value and subtract 1 from it. So this is going to take the y, which is 5, subtract 1, we get 4, and reassign that to the y. Okay, then z, let's take the z and we're going to double it. So z times 2, and reassign that value to z. So let's go ahead and compile and run. Okay, and we can see that the x started as 3, right? We added 1, now it's 4. Y started as 5, we subtracted 1, now it's 4. Z started as 8, we doubled it with the times 2, and now the z is 16. Okay, another way that we could write this, a shortcut, rather than saying x equals itself plus 1, we can do a compound operator plus equals, and then the 1. Okay, that's going to take the current value of x, add what comes after the operator, and reassign it to x. There's a compound operator for all of our operations. So for y, we can do minus equals to subtract. And for z, we can do times equals in order to double that value. So if I go ahead and compile and run, we should get the same result that we had last time. It's going to take the x value and add 1, right? Reassign it to x, takes the y value, subtracts 1, reassigns it to y, takes the z value, doubles it, right? Times 2, reassigns it to the z. Okay, and those compound operators exist for addition, subtraction, multiplication, division, as well as modulus. Okay, now another shortcut that we can do when we want to add or subtract 1 from a current value is, rather than plus equals with the 1, we could just do a plus plus. Okay, and that is a post increment. So let's go ahead and make a note of that this is a post increment. Okay. If I wanted to, I could put the plus plus in front. So instead of behind the value, I'm going to put that plus plus in front of the value. Now that's called a pre-increment. Okay, now to demonstrate the difference between a post-increment and a pre-increment, we're going to go ahead and do some math here. So x is 3, y is 5. Let's make the z be a pre-increment. So we're going to have z equal the x, and then let's multiply that times, and then a pre-increment of the y. Okay. Then we'll copy this, and we'll paste it. And then let's make a new variable. We'll call this one a, so we can compare. And we'll use a post increment. So y plus plus is a post increment. And then we'll change these to a's so that we can see what those look like. Output, oops, increment. So here we're going to check the post increment, and then here we're going to check and look at the pre-increment. So we'll clean this up a little bit so we can look at it. All right, now let's talk through it before we run and see what happens. So this is going to take the current value of x, which is 3, it's going to multiply, and because this plus plus comes before the y, okay, that's a pre-increment, that means we're going to look at the current value of y, which is 5. We're going to increment it before we do the multiplication. So now the y value is 6, and 3 times 6 is 18. So the z should output an 18. And then when we come down here for our post increment, the current value of x is 3 times, and the current value of y, because y got incremented in line 10, is now a 6. So this value of y is 6, and we're going to multiply the 3 times the 6 to get 18 before we increment and make the y a 7. Okay, so let's go ahead and run that. And we'll take a look at our output. Okay, so here's our line 11 output, where the x was 3, okay, then times, and we incremented the y, which is 5, with the pre-incrementer. We incremented that to a 6. Okay, then we multiplied the 3 times the 6, and we got 18. Now in 13 and 14, the x is 3. Okay, then that's times the previous value of y, which is 6. Since it's a post-incrementer, we go ahead and use those two values to multiply. So 3 times 6 is 18, but then we increment the y value one more time from 6 to 7. Okay, so hopefully that helps you see the difference between a pre-increment and a post-increment. The pre-increment is going to increment the value of the variable stored in memory by 1 before it's used in the expression. The post-increment is going to first use the current value stored in memory for the variable in the math expression, and then after it calculates it, it will increment that value in memory. Okay, you can do the same thing with minus minus, and now instead of an increment, it's going to decrement. It's going to subtract 1 from the value stored in memory before it's used in the expression. And then we can have a post decrement that's going to decrease the value after the current value assigned is used in the math expression. So let's go ahead and run, and we'll take a look at that output. So x started as 3, y started as 5. When we have a pre-decrement, that's going to decrease the y value to 4 and then multiply. 3 times 4 is 12. Okay, for the post-decrement, we take the current value of x, which is 3, and the current value of y, which is 4. Then we're going to multiply those together. We get 12, and then we decrement the y from 4 to 3.